Hi everyone. I figured we would do a little bit of a limits review. One, because final exam's coming up, and two, because next week we're going to be doing a little bit of work with something called L'Hopital's rule, which has to do with limits. So way back in chapter 1, we talked about how to find the limit of a function. So if I wanted to find the limit as x approaches 1 of this function, x squared minus 5x plus 1 over x plus 3, we discussed a bunch of different methods to do that. The first method was always to just directly try substituting in the value that x is approaching. So first thing I always try when I'm evaluating a limit expression is to just go ahead and substitute 1 in anywhere I see an x. So 1 squared minus 5 times 1 plus 1 over 1 plus 3. And I'm just going to simplify the top and the bottom. So 1 minus 5 plus 1 over 4 gives me 2 minus 5 over 4, which would give me a limit of negative 3 over 4. So if this is a numerical value of, an integer, a fraction, whatever, that means that our direct substitution worked. There's going to be times where we can't just substitute in and it's going to work out to be something like this. We said that in that case, what we'd want to try to do is try to factor. So if direct substitution doesn't work, which I will try here first, but if for some reason it doesn't work, which in the case that it doesn't, usually that's because something in the denominator makes it 0. So if I try to plug in 5 here into my denominator, 4 times 5 squared minus 100 would give me 4 times 25 minus 100, which would give me 100 minus 100, which we know is going to be 0. And that's a problem because we never want our denominator to be 0 because that's an undefined value. So if this doesn't work, and you could plug into the top two and see that it wouldn't work either way, but basically what we want to identify is if the denominator is 0, direct substitution isn't going to work. So what I would want to try to do instead is try to factor something out, maybe both in the numerator and the denominator, and hope that something's going to cancel that's going to allow me to use direct substitution once I cancel out whatever the problem is. So if I want to factor this, I'm going to go ahead and notice that I have a common factor of x, my numerator. So x squared minus 3x minus 10. And then I could take out a 4 here, and that's going to leave me with x squared minus 25. And nothing cancels yet because 4 and x aren't the same thing. So I'm going to go ahead and keep on factoring here. And I haven't substituted in anything yet, so I'm keeping the limit notation as I do this. So I can factor this into x minus 5 and x plus 2. And then the denominator, difference of two squares, will give me a 4 times x minus 5 times x plus 5. And at this point, I'm noticing that I have a common factor of x minus 5 that I can get rid of. So I'm left with the limit as x approaches 5 of x times x plus 2 over 4 times x plus 5. And once I've factored out and canceled, now what I'm going to do is I'm going to try to go ahead and plug the 5 back in there again, and hopefully that's not going to give me something that's 0 in the denominator. So I'm using direct substitution at this point. So 5 times 5 plus 2 over 4 times 5 plus 5. So that'll give me 5 times 7 over 4 times 10. So 35 over 40. And I can simplify that to 7 over 8. So if direct substitution doesn't work, try factoring. Maybe something will cancel out. And then once that cancels, go ahead and try direct substitution again. But there's going to be times that neither of these are going to work. Because if I do try direct substitution here, I'm going to notice that in the denominator, I'm going to get a 4 minus 4, which again is a problem because I can't have a 0 in the denominator. So direct substitution, not working here. This is not a polynomial form, so I won't be able to factor it either. So in this case, we said that we would want to use anything with square roots. We're going to talk about the conjugate of. So the conjugate is what we're going to be looking at of the term that has the square root in it. So the conjugate, remember, is the term, first term stays the same, second term stays the same. The only thing that changes about it is going to be the sign in the middle. So the conjugate here that I would want to use is going to be x plus the square root of 3x plus 4. And what I'm going to do is I'm going to multiply this quantity to both the top and the bottom of the fraction. So limit as x approaches 4 of the numerator times its conjugate, and then over x minus 4 again times the conjugate. And what we were originally doing when we talked about these problems back in chapter 1 was we wanted to identify the pair that were the conjugates, and we're going to multiply only these two out. So I'm not going to actually touch the denominator. I'm actually just going to bring that over into my next step. But basically what's happening in the numerator is that you are going to have to FOIL this out because this is technically a binomial times a binomial. So when I FOIL, x times x is going to give me x squared. X times the square root of 3x plus 4 is plus x times the square root of 3x plus 4. My inner terms is negative root 3x plus 4 times x. So that's going to be a minus x times the square root of 3x plus 4. And then my last quantity is negative that times positive that. So I'm going to have a negative. And then the square root of that times the square root of that is actually just 3x plus 4. And just be careful of that minus sign here. That's going to have to be distributed out to that quantity at the end. So that's why we want to be careful about parentheses there. And then the denominator, I'm actually just going to keep as x minus 4 times the conjugate. So I don't want to multiply this out. But I can notice that there's definitely some things in the numerator that I can simplify. These terms are going to cancel. And then I can also distribute out that minus. So I'm going to get an expression, limit as x approaches 4 of x squared minus 3x, and then minus 4, and then all over x minus 4 again times the conjugate. So it doesn't really look like this is helpful because there's nothing in the top and the bottom that are exactly the same that I can cancel, but hopefully I will be able to still do something with this. So here's where the factoring is going to come in. So I'm going to try to factor this. So I can factor that into, let's see, x minus 4 times x plus 1. And then again, just bring down that denominator stuff. And here's where the cancellation is going to happen, because now I'm noticing, and this is the reason why I didn't multiply out in the denominator here, is now I'm noticing I have a common factor of x minus 4 that can go away. So what I'm left with is the limit as x approaches 4 of x plus 1 in the numerator. And then I'm just left with the conjugate in the denominator. So x plus the square root of 3x plus 4. And then at this point, now that I've canceled, I'm going to go ahead and try direct substitution again. So my numerator is going to become 4 plus 1. Denominator is going to become 4 plus the square root of 3 times 4 is going to give me 12 plus 4 is 16. So this becomes 5 over 4 plus 4. And that gives me 5 over 8. So my limit here ends up being 5 over 8. After all of my conjugate and my factoring and my canceling, I was able to use direct substitution. So then the last limit that we talked about were limits to infinity. And we said that these were a little bit different. We talked about these a little bit later in the year. This wasn't in chapter 1. But we said that if the limit is approaching infinity of a function, what we wanted to do, if this was in polynomial format, meaning polynomial top and bottom, was I wanted to identify the highest degree of the denominator, which was an x to the third. And I wanted to take that x to the third and I want to divide it out in every single term. So the limit as x approaches infinity of, I'm going to divide every single term by x to the third. Both top and bottom. And whatever terms can simplify, I can simplify these terms because I can get some x's to cancel. I can simplify these terms because I can get some x's to cancel. That's going to tell me that the limit as x approaches infinity, I'm going to have 3 over x plus 27 over x cubed. And then this is going to become a 1 and then minus 27 over x cubed. So then I want to go ahead and take the limit of each one of these separate terms. So I'm looking to take the limit as x approaches infinity of 3 over x plus the limit as x approaches infinity of 27 over x to the third. And then do the same thing with the two terms in the bottom. Limit as x approaches infinity of 1 minus limit as x approaches infinity of 27 over x to the third. And we said that there was a rule that said anytime that there was something in the form of constant over an x to any power, all of these limits of the terms in that form are going to all go to 0 because the limit as x approaches infinity of a constant over a variable is always going to be 0. So my numerator, I know, is going to be 0 plus 0. My second term in my denominator is going to be minus 0. But we said that there was another special rule that we talked about that said a limit as x approaches infinity of a constant is actually just the constant. So the limit as x approaches infinity of 1 is actually just going to be 1. If it was the limit as x approaches infinity of 3, that would be a 3. So it's whatever the constant is here. So if I simplify that, that gives me 0 over 1. So my limit here actually just becomes 0. So now I'm going to have you guys work on some limit review practice. Let me know if you have questions.